Welcome to solverfy.
Hello everyone, today we're doing chapter 19, problem 36, and this problem asks us to draw the product of each acid-base reaction and use a pKa table in Appendix A to determine if the equilibrium favors the reactant or product. So in terms of which side the reaction will favor, well, the reaction is going to favor the side with the highest pKa value, and the reason for that is that the highest pKa value is most likely the pH is most likely not going to be able to attain that higher pKa value, so most likely that product will exist in its protonated form, which is its favorable form. So if you start with A, we have this carboxylic acid and we have this potassium terbutoxide, so we have an acid-base reaction to form this benzoate conjugate base and protonate the potassium terbutoxide to its alcohol form. Now, if we look at the pKa's, well, the pKa of our starting acid is around 4.2, while our now conjugate acid is now 18. So because the conjugate acid has a greater pKa, their equilibrium will favor the products. Now, what about in B? So we have this alcohol, we have an ammonia, and we're going to get the conjugate base, being a deprotonated alcohol, and the conjugate acid being ammonium. And the acid to begin with had a pKa around 16, and then the conjugate acid has a pKa around 9.4. So obviously, this alcohol is most likely to be staying in its protonated form, so the reaction will favor the reactant side because the acid has the higher pKa than the conjugate acid. So now in C, if we start with C, we see that once again we have an alcohol, we have sodium amide, which is even a stronger base, and we are going to deprotonate this to our conjugate base and our conjugate acid. And just looking at pKa's, well, the pKa of the starting acid is around 10, so the phenyl group, and a pKa of ammonia, which is actually not going to have any charge on it. The pKa of ammonia with no charge is going to be 38. So obviously it's very unlikely that we're going to go above 38. So this is going to be staying in its protonated form. So reaction is going to favor the product side. In D, we're going to use this acid is going to be deprotonated. So now we have this metal, which is going to dissociate to its carbanion and lithium plus. So carbanion is now going to act as our base to form methanol, which is going to have a pKa of 50, while this acid is going to have pKa of 4. So it's very obvious that methanol wants to be protonated, so this reaction is going to favor the products. Here we have sodium hydride and this alcohol, so the alcohol will be deprotonated into its conjugate base, and then we're going to form hydrogen gas. So hydrogen gas is a pKa of around 35, and this alcohol is a pKa around 16, so it's very apparent that hydrogen would rather not be H- and rather be H2, so reaction is going to favor the product side. Last but not least, this alcohol, if we deprotonate this in F, with this phenyl group, and sodium is going to dissociate here to form now a bicarb. So sorry, just a carbonate anion. So carbonate has a pK of 10.2. Well, this has a pK of a 10.2 as well, actually. So we have the same pKa for the starting acid and the conjugate acid. So an equal amount of starting and product material are going to be found. So unfortunately, there's no actual difference here. So because of that, the pKa of this acid and the pKa of this conjugate acid are going to be the same. So uh, there's no going to be any favored or favor side on equilibrium. They're both going to be equal.